the last few videos, we understood Newton's laws of motion. In this class, we'll try to understand the part of Newton's laws of motion, that is buoyant force. Yeah, Newton's laws of motion. In this, already 3 to 4 parts we explained based on free body diagram. And now we're going to understand regarding the buoyant force. See, what is this buoyant force means? Any object, let us imagine the water is there. Suppose you just immerse one object into the water. Let us take its density is less than water. Let us take the plastic body. So what will happen? We just try to immerse the body into the water. The body will pop up. That means the body will come upward direction. That means who makes this body to come up? Children, right? So if any body object we just leave on the surface, now it will go towards the earth, towards the center of the earth. That is because of gravity, all the bodies will go towards the center of the earth. But here, what makes or which force makes the body to come up? The against the gravity, that is what we call buoyant force. Understood, children? The buoyant force is a force which will acting inside a fluid on a body, which will always act upward direction. You can see here in this picture, the boat, it is there inside the water. Here the upward force acting on the boat, that is why the boat is just floating on the surface of the water. Compared to the density of the boat, here density of the water is more. Okay, that's why the body is just floating on the surface of the water. So what is this buoyant force? It will be act in case of solid, liquid or gases. Let us check. In case of the solids, this buoyant force does not exist. Only in case of liquids and gases, this buoyant force will going to come. So what this liquid and gases combinedly, what we call it as a fluid, children. So fluid will have the nature to flow. The substances what we call as the fluids, which have the nature to flow. Suppose just release the water or pour the water on a plate, what will happen? Just it will just float, or else release the gas to the atmosphere. What happened? The gas will just going to flow. So this nature they have, no? That's why they're called as a fluids. So matter we're going to divide into two parts. One is solids, one is fluids. So again, the fluids are of two types, liquids and the gases. In case of fluids, we're going to observe this buoyant force. Understood, children, what is buoyant force and how it is related to density means? See, buoyant force is nothing but how much the upward force acting on this body. Why this upward force will come? Because of the weight of the body is acting downwards. When weight is acting downward, to balance that, the buoyant force is acting on this body. So buoyancy force is nothing but the weight of the body or weight of the fluid displaced. You can observe in this red color what they quoted in the figure, boat color. Here our red color shows that water displaced by the boat. When the boat is immersed into the water, no, how much of water is displaced, that is shown here. So that means when that is buoyant force is also is equals to the weight of the liquid displaced. Okay, when the body is immersed into the water, how much water is going to displace by this body? That is nothing but the buoyant force. Why water will displace? Because of this buoyant force is acting upward, no, because of that. So one more thing, just try to understand density, amount of matter present in a unit volume. So mass per unit volume is nothing but density. So density means number of particles are more in a given volume, so density will be more. Or if in a given volume number of particles are very few, so density will be less. So density depends upon mass, how much mass is present in a given volume, so density will be more. Understood, children? So density formula, so density is mass by volume. Suppose you want to find a mass, we can write density into volume, just cross multiply like this. So mass given by density into volume. And here, see, according to the buoyancy, you will get that weight is always is equals to m into g. There's a formula for weight, right, children? So in the mass, here mass is there, that you're going to replace with density into volume. Okay, children, this is I'm replacing with mass, replaced with density into volume. So rho into V and G is like that. Just you write this one. So weight will be also is equals to, we can write density into gravity into volume, where volume is displaced liquid. Here V indicates the volume of displaced liquid by the body. How much the body will going to displace the water, that will be is equals to here this B, and here T, rho indicates the density of the body, and g is the acceleration due to gravity on the surface of the earth. This is equals to 9.8 meters per second square. Okay children, this is on the surface of the earth. This is constant. They won't give while solving the problems. Okay, this equation will calculate buoyant force acting on an object displaces a certain volume in meter cube. Okay, let us see some problems you can be able to understand easily children. Second. Yeah, here try to see there's some problems are there children. You can able to solve these problems, just check. Yeah, here see first problem given. A block of wood is floats 4 by 5%. Okay, 4 by 5 of its volume inside the water, but floats it completely in the water. That means that two containers are there. Children, try to understand the question clearly. Two containers are there. In one container, it is completely filled with water, and other container is filled with oil. Okay, when the one block of wood just immersed into the water, what will happen? It 4 by percent. That means some percent will be outside and some percentage of the volume will be inside the water. Like this, it's going to submerge. When you same block you just immersed into the water, it will be completely float on the surface of the water. It will completely float on the surface of the water they given. Now, what is the density of this oil is what we need to find out. And the given provided density of the water is 1 gram per cc in the CGS system. But see, you can see, observe the answer, it is there in SI system. So that you convert density of the water in the SI system, that is 1000 kg per meter cube. This is the density of water in SI system. Now see, you know the formula, buoyant force, the weight of the body. Okay children, the weight of the body in like in water first. If water will be is equals to weight of the body in oil. So weight, how can we write children? So far we see the formula right in the last. See here, weight is equals to rho g into v. Okay, use this formula only. So weight is equals to, we can write. Yeah, here I can write children. Yes, weight of the weight in water and weight in oil will be same. So weight in water we can write it as rho, density in water, volume in immersed in water, and the we can write gravity is equals to, this is the formula, right? W is equals to rho gv, what we got from the last slide, right children? You can observe the formula here, what we got, W equals to rho g into v. Okay, so based on this formula we wrote that one. W is equals to density in water, volume in water into gravity, and density, this second one we can write, yes, density in oil, volume in oil, and gravity. You can observe the left hand side and right hand side. The G will be same, right? So we can cancel the factor G. Now density of the water, you know children, given density of the water is 1000 grams per cc or 1000 kg per meter cube, and volume of the water submerged is 4 by 5. Okay, this is what I given in the problem. You can observe here 4 by 5 of its volume. So 4 by 5 times the initial volume. 4 by 5 times the initial volume, that is equals to density of oil, what we need to find out, and volume of the water. Volume, no, it is completely immersed from upper only, right? This is what are given data. So here again you can observe V naught and V naught is almost common terms on the both the sides. So that will also going to cancel children. So here V naught and here V naught cancel. So now remaining rho naught is equals to, left hand side you can observe 1000 into 4 by 5 is there. So simplify this, 5 ones are 5 2s are 200 into 4, 2 4s are 8. So this is approximately 800 density, unit is kg per meter cube. Understood children? The first question answer is 800 kg per meter cube. Like this we're going to solve the problem. Because I think this is the question number 11. Answer is B. Understood children? Question number 11, answer is B. So here you need to remember this formula. Weight will be same in both the conditions. When it will just balances the density and the water volume, how much immersed body volume just balanced. Yeah, let us take second problem. See, second problem given that two solids A and B, okay, two solids A and B float in water. They are just floating in water. It is observed that A floats with half of its volume. A floats with half of its volume immersed, and B, this is the volume of A just immersing, and the B floats with the 2/3 of its volume immersed. Okay, this is the volume of B immersed. Then the ratio of their densities. We need to calculate the ratio of the densities. Again, use the same formula. Yes, children, 12th question. See, volume of A, weight of A is equals to weight of B. Yes, see the next problem, 12th one. 12th one question is given like this. The two solids are there, okay, A and B are when submerged in water, no? The first body will float by 1/2 of its initial volume, and second body floats with 2/3 of its initial value. Then what is the densities or ratio of their densities we're going to calculate. Okay, let us write first body, volume of A. Okay, children, the volume of A they given is half of the volume in water, and the volume of B, okay, second how much it is immersed, it is equals to 2/3 of the volume in water. This is what they given. And now you know the relation that weight of A is equals to weight in B. Okay, children, both the weight are equal. Now right, you know the weight formula. This formula only, same formula you just substitute here also. Density of A and volume of A and gravity is equals to density of B, volume of submerged in B into gravity. And again the gravity factor is same both sides, it will going to cancel. Then density of A and volume of A you know already. So you need to find the ratio of the density. So density of A by density of a B is equals to, you just send V of B here only, send this one down. So it will come V of A come down. Understood, children? Just I'm taking this ratios. Okay. So rho A by rho B, what you will get, density of A by density of B is equals to volume in B by volume in A. And you know this relation, no? Just substitute this one here. So volume in B is 2/3 in volume in water, by here it is 1/2 of the volume in water. So both terms are same here, they will cancels, and here remaining 2/3 into 2/1. So cross multiply, children, we will get this ratio. 2 2s are 4 is to 1. This is your answer. Sorry, 4 is to 3 is your answer. Okay, so density of A is to ratio of densities of A and B will be is equals to 4 is to 3. Okay, children, let us check answer is correct. Yes. It is actually the 12th one, children. Answer is A. This is the correct answer, not this one. Follow this. Answer A. 4 is to 1 is the correct answer. I hope this is clear, children. Yeah, see the last problem. A block of ice of density. Okay, density of the ice given has 0.9 grams per cc, and its volume. Okay, this is the volume of ice given how much, 100 cc, floats in water they given, and then the volume of the ice inside the water is, we need to find what is the volume will be inside, submerged inside the water, we need to calculate, children. Understood? And here no need of converting this grams per cc. Why? Because all there in the SCGS system only. cc means centimeter cube, all there in centimeter cube only. That means all there in CGS system. So no need of converting this density to SI system. Okay, children, let us solve this problem. Yeah, 13th question. Given, children, let us write the given data. Given, that is density of a ice, rho symbol is for density, children. Density of a ice is given as 0.9 grams per cc. And the density of a water, we know density of water is 1 gram per cc. Understood? And the next what is given? Water weight in ice, this is given is equals to weight in water. We know this relation. Weight in ice is equals to weight in water, we can write. And weight in ice, we can write it as volume in ice, right children, into density in ice into gravity. And same time we can write here also volume in water into density of the water into gravity. Again, the both the sides gravity is same children, so it will be cancel out. So what left? Volume of ice is there, right children? So volume of a ice, they are given, right? In volume of ice is the body in ice is 100 cc. So write this one, 100 centimeter cube into density of ice is 0.9 grams per cc. That will be is equals to volume of water into density of water is 1. So now you can see this is 1 into anything is this thing only. So volume in water is equals to here 0.9 by 100. So we can write 100 into 9 by 10. 0.9 we can write it as 9 by 10. So 10 ones are 10 times. So 1 0 get cancelled. So 10 into 9 children, volume of water in water is 9 into 10, it is 90 cc. Understood? This is your answer. Check which option is correct. I hope just to check. 90, this last out. Say B, option B is the correct then. Okay children. So for this 13th question, option is B. Understood now? 13th question option B, 12th question option this, and the first question option we got 800. Okay, these are the 3 questions children. Try to solve these questions and try to understand. If not, no, we'll just discuss later. I hope this is clear everyone. Yes. Thanks for watching children. Have a nice day. Bye.